In this video, we will show you how you can use Rafay's Terraform provider to manage the lifecycle of Amazon EKS clusters. We will break this down into typical tasks that operations and SRE teams have to perform over the lifetime of a cluster. Rafay provides a verified Terraform provider at Hashicorp's Terraform registry. Day 1. We'll start with day 1, where we will configure and provision an Amazon EKS cluster. We want the EKS cluster to be provisioned in a Rafay project called GitLab. We want to provision our EKS cluster with a default cluster blueprint. We want the user to be able to provide the cluster name and Kubernetes version as user input during provisioning. In our case, we have configured the cluster with a single node group with one worker node. Let us now apply the Terraform plan to provision our standardized EKS cluster. We have provided the necessary user input with the cluster name and Kubernetes version during Terraform apply. Once our EKS cluster has been successfully provisioned in the Terraform project, the default cluster blueprint will be automatically applied and the EKS cluster will be brought to the desired state. On day 2, when an application team requests for increased cluster capacity and we decide to scale the node group. As you can see, our EKS cluster has one node group with a single worker node. Let's make the change in our main.tf file by updating the desired state to 2 worker nodes. Let us use Terraform apply to bring our EKS cluster to the desired state. The Rafay controller processes the changes requested via Terraform and scales the node group to 2 worker nodes. Once the process is complete, we can see that Rafay EKS cluster dashboard is reporting 2 worker nodes in the node group. On day 3, an administrator makes some manual changes to the EKS cluster to accommodate an urgent capacity increase request for one of the application teams. Specifically, the admin scales the node group from 1 to 2 worker nodes. The admin also deletes all the cluster labels at the request of the application team. Manual out-of-band changes like this make the EKS cluster drift from the state in the Terraform state file. Admins can optionally remove this drift and bring the cluster back to the desired state in just a few minutes. When the admin uses Terraform apply, notice it provides a warning that the current state and the state file are not in sync. It then brings back the EKS cluster to the desired state by reducing the additional worker node in the node group and adding the cluster labels back. On day 4, we want to upgrade our EKS cluster's control plane and the node group to the latest Kubernetes version, that is from 120 to 1.21. Let's make the change in our main.tf file and use Terraform apply to bring our EKS cluster to the desired state. The Rafay controller processes the changes requested via Terraform and performs the upgrade of the EKS cluster's control plane, the attached node group, and all the managed add-ons. Once the process is complete, we can see that the cluster's control plane is reporting the new Kubernetes version. Let us access our EKS cluster using Zero Trust kubectl to check the Kubernetes version for the nodes in the node group as well.